The second example for Newton's method, and it actually has halving the interval as well, is given here. So you're given a function, again, it's equaling 0 because they're trying to find the root, and it's between 0 and 1. And our first part of the question is show it actually does have a root between 0 and 1. So I might just section this off. Show it's a root, so I have to find f of x when x is 0 and x is 1. So f0 equals 2 by 0 squared plus 0 minus 2, which is negative 2, less than 0. So I'm hoping f of 1, let's rub that out there, f of 1 is greater than 0, which it's going to be 2 by 1 squared plus 1 minus 2. So that's 1. So that's greater than 0. So therefore, a root exists between x equals 0 and x equals 1. Part B. Use the method of halving the interval twice to find an approximation. So our interval, it's a good idea to draw the interval, 0, 1. And we know at 0 it's negative and at 1 it's positive. So halving the interval, and sub in f of a half equals 2 by a half squared plus a half minus 2. Half squared is a quarter, 2 times a quarter is a half, plus a half minus 2. So it's 1 minus 2, which is negative 1, less than 0. So a half is less than 0. Therefore we can cross out that one because they're both 0. And we know the root is somewhere between a half and 1. And they say to do it twice, so we're going to halve it again. So halfway between a half and 1 is 3/4, 0.75. So we'll sub in 3/4. I find it easier to work with fractions than decimals. But if you want, not half. If you want to put it on the calculator and do it as a decimal, you can. But I think it's easier to do it like this. So 3 squared is 9, so it's 18 on 16 plus 3/4 minus 2. And that equals minus an eighth, which I did do on the calculator, which is negative. So at minus 3/4, it's also negative, if you can see that. So we're going to cross out this area here. And what we've found is by halving the interval twice, that between 1 and 3/4 is where the root lies. That's part B. We'll do part C over the page, and that's using Newton's method. Now again the question is, which value do we take for A in Newton's method? And if you have a look at it, so we're here. Oops, we're not there. We're here. Dearie me. So we're between 1 and 3/4. That's where the root is. And we need to know which value do I take. Do I take 3/4 or do I take 1? Well, f of 1, if I just move that up a bit, f of 1 was equal to 1. Keep pressing the wrong thing. F of 1 equals 1. And f of 3/4 is minus an eighth. Now, minus an eighth is closer to the axis than 1 is. So that's going to inform my choice. I'm going to take 3/4 as my A value. So the A we're taking is 3/4. So we need to find f of A and then f dash of A. So f dash x is 4x plus 1. And we're going to sub in A. So 2 into 3/4 squared plus 3/4 minus 2 equals, and f dash A equals 4 by 3/4 plus 1 equals 3 plus 1, so we know that's 4. And f of a equals minus 1/8. So I can sub it into the formula that a1, our new approximation to the root, equals 3/4 minus, no actually no I'm going to do, I'm going to rub that out, and we're going to write Newton's method, just so you remember it. So a1 equals a minus f of a on f dash a. a1 equals 3/4 minus f of a was minus 1/8 over, and f dash a is 4. So if I continue it up here, that's 3/4, that's going to become a plus, and that's going to be 1 on 32. So the new approximation to our root, if I take a common denominator or put it on your calculator, that's 24 plus 1. So 25 on 32. But 25 on 32, I just worked out, is approximately equal to 0.78125. Now our original, the first root we started with was 3/4, 0.75. So quite close to that, so we're getting really quite close to the root. But the question only asks us to do it once. The last part asks us to solve the equation and actually find the roots or approximations to them by the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4 by a by c all over 2a. So minus 1 plus or minus 1 plus, what's that, 16 over 4. So I just said an approximation to it. I meant like a decimal approximation, but this obviously gives an exact value. So it's minus 1 plus or minus root 17 on 4. So you can see we're finding two roots here, and we're trying to approximate the one that's between 0, 1, and then we reduced it right up to near 0.78. So let's see what the decimal approximation of these two numbers are. The one we're interested in is the first one. You can see it's extremely close to the one we got before, 0.780776, and the one on the last page was 0.78125, I think it was. So very close. And just to make the point, Newton's method gives a much closer and quicker approximation to the root than halving the interval.